In triangle BUG, the measure of angle B is 78 degrees, the measure of angle G is 42 degrees, and G is equal to 99. So we have two angle measures and the length of the side G, which is across from angle G. Find the length of side B to the nearest tenth. So the first thing again I would do is draw a picture. That's very important. And you can draw any old triangle. You don't need right triangles in order to use the law of sines. That's particular for law of sines. So angle B is 78 degrees, angle G is 42 degrees, and the length of side G is 99. We're looking for the side that's opposite angle B. So since I'm looking for sides that are opposite the angles that are given, we can set it up. 99 over sine of 42 is equal to x over sine of 78. So now we have 99 sine of 78 all over sine of 42. Put that into your calculator, and we get what x, hence what b is. Approximately equal to. So to the nearest tenth place we get 144.7. In triangle XYZ, the measure of angle Y is 125 degrees, the measure of angle X is 18 degrees, and the length of side Y is 112. Find the length of side Z to the nearest hundredths. Draw a triangle labeled XYZ. Angle Y is 125. Measure of angle X is 18. And the side that's across from Y is 112. And we're looking for side Z. And we don't have an angle measure here. So what we need to do is find the third missing angle by taking the sum of 18 and 125 and subtracting that from 180, because the sum of three angles of a triangle is equal to 180, and we'll have angle Z. So that angle measure is equal to 37 degrees. Now I can set it up. We're looking for side Z over the sine of 37 degrees, which is the angle measure for Z. That's equal to 112 over sine of 125. So I want to isolate Z. I'm going to keep it to the left and cross multiply these two. And this is how I'm going to put it into my calculator. And in effect, we'll get what the value of the length of the side for Z is to the nearest hundredths. And that is 82.28. A baseball fan is sitting directly behind home plate in the last row of the upper deck. The angle of depression to home plate is 30 degrees. Okay, so the fan has a line of sight that looks like this, and then we have a direct diagonal. The angle of depression is 30 degrees. And the angle of depression to the pitcher's mound is 24 degrees. So I need another diagonal going out from the fan to the pitcher's mound, and that is 24 degrees. So that's the same thing as the angle of elevation from the pitcher's mound to the fan, which goes inside here. The distance between the pitcher's mound and home plate is 60.5 feet. How far to the nearest foot is the fan from home plate? So this is x. So we're looking for the side, x, and the angle across from it is 24 degrees. So x over sine of 24 is equal to 60.5 divided by sine of, you have to subtract 24 and 30 and get 6 degrees for inside this triangle here. So sine of 6 degrees. I'm only going to cross multiply these and have x to the left, so that's equal to 60.5 times sine of 24 degrees all over sine of 6 degrees, in which case to the nearest foot we get 235. So the fan is approximately 235 feet from home plate.